In order to make it so that the spaceship will move around, what we're going to need to do is add a script to this root object, the spaceship. To make a script, all you need to do is go to any folder. We're going to do it in scripts. Right-click, create C# script, and it'll create a new one and let you rename it. We're going to rename it to ship controller, since that's what we're going to be making. Now, right now it's just sitting in this folder, not really doing anything. In order for it to affect this ship, we actually have to add it as a component. So we can do the regular add and put it on, or we can just drag them in, whichever is easier for you. So in order to edit it, what you do is just double click and it should open up in Visual Studio or whatever editor you have it set to. And you'll see it always starts with the same pattern, which is the class name that you named it, and also that it inherits from mono behavior. And this is important. Any script, in order to be attached to a game object, needs to be inherited from mono behavior. There's instances where you can create classes that don't have this, but we'll go more into that when we get to those situations. What mono behavior does allow you to do, though, is it does give you access to certain parts of the game object, such as the transform here, which is essentially its position, rotation, and scale. Also lets you do stuff with the name, parenting, and hierarchy, things like that. There are also a way to access these other components, so that if you want to make, let's say, changes to the rigid body, you can. But to do that, we have to actually make references or pointers to it essentially. So what we're going to do is we're going to do that next. So I'm going to jump over here. I'm going to make a public rigid body and call it ship rigid body. And right now this is essentially a rigid body, but it's not pointing to anything. It's just empty. But what we want to, in order to use it, what we need to do is go over, save this so that it's reflected in Unity. Wait for a moment, and what you'll see is that a little pointer will appear here that's empty. See, it lets us assign a rigid body. Technically, you could do any rigid body in the scene, but for our purposes, what we want is to actually reference this actual one on here. There's also a way to do it programmatically, but I find this is the easiest way to just get started and start going with it. So now we have this rigid body assigned to that variable. So if we go back here, what we can start doing is actually making changes on it. So what we're going to be doing primarily is in the update function. The update function briefly is just called every frame. It's not precise. There's different time between the frames. So sometimes it might be, let's say, half a millisecond. Sometimes it might be a full millisecond. It varies depending on how long it takes to draw everything and other factors. But there are other functions that you can call that are more consistent, and we'll get into that in more detail. But if you're interested in it, you can look at the execution order of event functions, and they do talk about how all of these go from the start during initialization, fix updates, things like that. So for now, we're going to keep it simple and just leave everything in update. But that does mean we all are going to have to use delta time, which is just how much time has passed since the last update to make sure that our physics changes keep up and make sense with the frame rate that's currently going. So in order to query input, what you want to do is actually use the input function and then do a get key, because we're going to first do keys. Key code. This tells it what key you're interested in listening to. So in this case, we're going to do W first. And this will be true whenever that key is down. So every update, if this key is down, this will become true. So we're going to do an if it's true. Then we're going to want to do something. So what we're going to be doing is actually adding velocity or thrust to this rigid body. So the rigid body, add force. And then what we're going to do is we're going to choose transform forward. So what transform forward is it's actually the the z direction, regardless of which way the ship is rotating. So if it's facing this way, then the z direction would be that way. So it's always facing the way the ship is facing in this scenario. So that's what we want transform, which is pointing to itself, where the ship controller is attached to forward, and we're going to multiply that by just time delta time for now, so that it makes sure it updates properly and doesn't scale weirdly when you're pushing the key down, depending on the frame rate, because you want it frame rate independent essentially. So with that in place, when we hit play, what we should see is that when we push down on the keyboard, you'll see that we start to move. We are moving at a very, very slow pace, and you can I don't know if you can see it on the screen, but we are moving forward. So this isn't really desirable, but it's a place to start. So the next thing we want to do is actually tweak that. We want to tweak it so that we can make it so it's closer to what we want. It all comes down to game mechanics later on, but for now we just want to see it move at a better rate. So we're going to create a float called thrust. Let's call it thrust multiplier. And we'll make it 1 to begin with. Multiplying a number by 1 just is the same number, so we're just going to start there and leave it as a public float so that we can alter it. Because one of the really neat things you can do in Unity is when you add a variable like that, you can go into play mode and actually tweak things to see how they work. So right now we have a thrust of 1, still the same as before. We can set it up to, let's say, 100 and say, oh, that's a little bit better. So I'm just going to set this to 0. We still have a velocity on the rigid body, so it's moving. But we could set this to 200, see how that works. Yeah, that goes a little bit faster. I'm going to leave it at 200 for now and add that as the default. So we were in play mode, so it kicks it back to the original value. That's the nice thing about play mode, but also kind of the pain is that if you change things, they won't save. But it's nice because you can test things, find what you like, and then add it later. So we're going to set that to 200. That'll be our thrust multiplier for now. So the next step will be to add some movement in the left and right direction. So we actually want to be able to rotate. So the very first thing we're going to do is actually just get a rotation. But we also want to save that value. So I'm going to make a new variable called rotation, so we can keep track of it. Just set it to 0 for now. And what we're going to do is set this rotation to the, let's see, ship, rigid body, rotation. We want the Euler angle, y. So what this is it's the same rigid body that we were doing before. It's the rotation element. The Euler angle is just turning it into more of a number coordinates similar to what we would see in this window. We'll get more into angles and stuff like that and rotations at a later point. For now, all you really need to know is that it's the degree that it's rotated in the y, which is essentially the direction it's facing. So now that we have that, we're going to do the left and right so that when we hit the A and or D key, it will move us left and right as we're traveling. Before we do that, we're actually going to set another variable up here, public float. We're going to do rotation speed. And we're going to also set that to 1 for now. And then we're going to do the same if for the key codes. Input, get key, then do key code A equals true. And we'll just copy paste this to get the D. Now we already have captured the rotation up here, so what we're going to do is take this rotation. For A, we're going to minus equals, and then choose our rotation speed times time delta time again. And after we do that, we actually have to set it to the rigid body. So we take the rigid body and rotation element. Now we are going to use Quinterion here from Euler. Change the x to 0. This will be just our rotation, and this will be 0 again. So effectively what this is doing is figuring out what our rotation actually is in Euler angles for the ship. When you're holding A and it comes through here, it's going to minus it by the rotation speed times delta time so that it's scaled properly. And then it's going to reapply it to the ship's rotation by creating a new angle based off just the uh, new rotation from there. So this is for the A key, and we're just going to do the same for the D key, but the difference is this will be going the other direction. So let's try that out. We'll have to give it a second to show. You'll normally know that it's compiled and everything because the new variables you put in will appear. So there we go, we have our rotation speed. So if we hit play now, we should actually be able to hit left and right and see some sort of movement, which is there, but it is really slow due to the speed not being set yet. So what we're going to do is start arbitrarily changing these to see how it works. So 20, it's still pretty slow it feels, so we're going to keep playing around with this till it feels a bit better. Let's try 100. Well, it feels a little better. Now when I hit forward and move, you can see I can actually move my ship around. Still feels a little slow, but one thing you can do later on is actually make different chip types based off this. So this might feel slow for what I'm doing now, but there might be a specific example where you want a ship that goes slow, in which case this is good. But if you want like a really fast ship, you could change these and make it much faster as far as acceleration, as far as everything else, so that it runs and plays and feels different. But that's the nice thing about the editors, you can play around there. One thing you'll probably noticing is that the camera isn't really following me around. The ship's moving. If I go off screen, I'll just disappear forever, unless I can get back here somehow. No, there I am. So I am able to move around, but the next step would be to add the components so that the camera will actually follow. So we're going to do that next.